So today we will be able to use the identity property and a tape diagram to write an equivalent ratio. So we have equivalent, so we're going to highlight equivalent. Equivalent means equal in value. Equal in value. To write an equivalent fraction or ratio, we can simplify the ratio. So we're going to highlight the word simplify. We're going to simplify the ratio. And you have heard the word simplify many times already. So just as a reminder, in words, what simplify means, it means to turn a fraction or expression to their lowest terms through division. So we're going to write division here. Another way to write an equivalent ratio or equivalent fraction is to do something called scaling up. So let's highlight that, scaling up. So scaling up means creating an equivalent fraction by resizing it through multiplication. So scaling up is creating an equivalent fraction by resizing it through multiplication. We're going to go ahead and practice simplifying ratios. We're going to simplify ratios through the identity property. So we're going to use the identity property to simplify. Now, when we use identity property, remember that means that we are essentially dividing that fraction by 1 because the greatest common factor of the numerator and denominator, when they're the same, it equals 1. So if we look at this example, 4, 6. We're going to take 4, 6 and simplify it. Well, to simplify 4, 6, we have to find the greatest common factor, or GCF, of 4 and 6. Well, the GCF of 4 and 6 is 2, because the factors of 4 are 1 and 4, 2 and 2. So 1 and 4, 2 and 2. The factors of 6 are 1 and 6, 2 and 3. And what do they have in common that's the greatest? It's that 2. So the greatest common factor is 2. So then we would have 2 over 2 written in that number 1. So we use that symbol number 1 because 2 over 2 equals 1 whole, or 1. And then we would divide 4 divided by 2 is 2. And that's supposed to be an equal sign right there. It kind of looks like a negative a little bit. So 2 divided by 2 is 2. And 6 divided by 2 is 3. So it's simplified to 2/3. So 4, 6 simplified to 2/3 utilizing the identity property by dividing both numerator and denominator by 2. Okay, now we are going to scale up ratios by utilizing the identity property. So likewise, we're going to create a equivalent ratio by multiplying the numerator and denominator by the same value. So if we're going to scale it up, that means we're going to take our fraction and we're going to multiply it now. Scaling up involves multiplying the numerator and denominator by the same value. So if I have 2/3, like what the original problem simplified to, if I started out with 2/3 and I want to scale it up by multiplying numerator and denominator by 2, I'm going to be back to that 4, 6 that was in that previous problem we just looked at. So 2 times 2 is 4, and 3 times 2 is 6. So it's scaled back up to 4, 6. Something called a tape diagram that we can use. So we're going to utilize a tape diagram to scale up ratios now. So if I have the fraction 2/3, if I have the fraction or ratio 2/3, 2:3, I can draw a tape diagram to represent the 2 and represent the 3. Well, the 2 is these 2 boxes. 1, 2. The 3 is these 3 boxes. 1, 2, 3. Well, if I want to scale this up by multiplying by 2, I would write a 2 in each box. So I have this 2, and then these 2's. And then I would count how many 2's I have there. On this first one, I have 2 2's. So that's really 2 times 2, and that makes 4. And then this bottom one right here is 2 times 3, and that makes 6. Here's the 6. So that's how you can see the fraction or ratio scaled up utilizing a tape diagram. So, write the ratio in fraction form and then utilize the identity property to simplify the ratio. Let's go ahead and highlight the word simplify because we're going to simplify. That means we're going to use division. We're going to simplify it by utilizing the identity property. So highlight identity property. And it says to start all of this, we first need to write it in fraction form. So to begin with, we need to turn the wording or the sentences into fraction form. So if I look at number 1, it says for every 6 dogs, let's underline 6 dogs, there are 8 cats. So the first thing we need to do is write this in the form of a fraction. Remember, order matters, so I must list the dogs first and then the cats. We're writing it as a fraction. Remember, there's 3 ways to write a ratio. This one specifically asks us to write it in the form of a fraction. So it's going to look like this, 6 over 8. So that's 6 dogs to 8 cats. Then we're going to simplify it by using the identity property. So since we're simplifying, we're going to be dividing. So we're going to put our division sign. We're going to write our number 1 for our identity property. And then we're going to put a fraction in there. Okay, we need to think about the GCF. What is the greatest common factor of 6 and 8? Well, the factors of 6 are 1 and 6, 2 and 3. The factors of 8 are 1 and 8, 2 and 4. That's all. So now we need to figure out which one is the greatest common factor. You can see that they have a 2 in common, and it is the greatest factor they have in common. So that means we're going to simplify by dividing both sides by 2. Because 2 over 2 equals 1. That's where we get that identity property. 6 divided by 2 is 3. We see that right here in our other factor. And then 8 divided by 2 is 4. And we see that right here in our list of factors that we wrote out. And now we're going to circle our answer. But before we do that, let's label the 3 and the 4. What's that 3 represent? 3 dogs. And what does the 4 represent? Cats. So we're going to put cats there. Now we can circle our answer. 3 dogs to 4 cats. So we took 6/8 and we simplified it to 3/4 by dividing, utilizing the identity property. Number 2, Alice cut a 12-inch string and Sarah cut an 18-inch string. So let's underline the important details. We have a 12-inch string and we have an 18-inch string. So we're going to write this in the form of a fraction. Okay, so to write this as a fraction, remember order matters, so we have to list the first item first and the second item second. So we have 12 over 18. And the 12 represents Alice's string, so I'm just going to write Alice right here. And the 18 represents Sarah's string, so I'm going to write Sarah right here. Okay, we need to utilize identity properties, so that means we're going to divide to simplify. So we're going to put our number 1, and then we're going to write our fraction inside. So we need to think about what's the greatest common factor of 12 and 18. You might be able to do that pretty quickly in your head, but if you can't, then you just list out the factors. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. We need to compare and see which one is the greatest factor that they have in common. So the greatest common factor is 6. They have the 6 in common and it's the greatest of the ones they have in common. So that means on the identity property, we're going to put 6 over 6, and 6 over 6 equals 1. So 12 divided by 6 is 2, and we see that here in that other factor right there. And then 18 divided by 6 is 3, and we see that right here in the other factor on that list. Now we're going to label what these numbers represent. That's 2 inches of string for Alice, so I'm going to put Alice right here. And then 3 inches of string for Sarah. Number 3. Matthew picked 24 apples, so underline or highlight 24 apples from the tree, while Rose picked 30 apples from the tree. So we're going to write this ratio in the form of a fraction. Remember, order matters, so we need to first put 24 over 30. And that 24 represents 24 apples. But this is for Matthew, so I'm going to put M with a little period next to it to abbreviate it. So Matthew's apples. And then the 30 is Rose's apples. So I'm going to put R and then apples. Rose's apples. Okay. We're going to simplify this, so that means we need to use division, and we're going to utilize the identity property. So make your number 1 and our fraction inside. We need to figure out what the greatest common factor is of 24 and 30. So off to the side over here, I'm going to list the factors of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are all of our factors of 24. We're ready to do the factors of 30 now. So the factors of 30, I have 1 and 30, 2 and 15, 3 and 10. Will 4 times something make 30? No. Will 5 times something make 30? Yes. 5 and 6. And when your factors go in sequential order like that, 5, 6, that means we have found all of our factors. Now we're going to look for the factor that is the greatest that they have in common. I'm going to start with the largest factor, 30, and compare and see if the other number has 30. And it doesn't. So 30 is not going to be the greatest common factor. Then I go to 15. Do they have a 15 in common? No. Do they have a 10 in common? No. Do they have a 6 in common? Yes. So the greatest common factor is 6, just like the previous problems. So we're going to put 6 over 6. And 6 over 6 makes 1. 24 divided by 6 is 4. We see it right here in our list, so that's 4. And then 30 divided by 6 is 5, and we see it right there in our list. So now the last thing we have to do is just label it. It's 4 apples for Matthew. So I'm going to put M apples, Matthew's apples. And then 5 is representing Rose's apples, so I'm going to put R apples for Rose's apples. And then circle our answer. It says for every 28 cars, let's highlight or underline, there are 32 trucks in the parking lot. So we're going to write this ratio in the form of a fraction. So this is going to be 28 cars over 32 trucks. Okay, we want to simplify this, so that means we're going to divide, and we're going to utilize the identity property. Okay, we're going to put our fraction in the center there. We need to think about what the factors of 28 and 32 are. So we're dealing with a little bit larger numbers here, and as you deal with larger numbers, it becomes a little bit more challenging because there's more factors that are associated to those larger numbers a lot of times. Okay, so let's go ahead and list the factors of 28. Okay, the factors of 28, we always start with 1 in itself, so 1 and 28. 2 will work because 28 is an even number. 2 and 14. Will 3 times something make 28? 3 times what?
7.
Does 3 times something make 28?
Yes.
Well, what then? 3 times what?
8.
Well, 3 times 8 is 24. And 3 times 9 is
27.
27. So 3 won't work then. So 3 is actually not a factor of 28. So we need to back up a little bit and erase that. So then we need to go to 4. So 4 times something to make 28. I think that's what we were thinking. We're thinking about 4 times something. What is it? 4 times?
7.
4 times 7. 4 times 7 makes 28. Will 5 times something make 28? No. How about 6 times something make 28? No. 7 times what makes 28? 4. And we already have that one, so that tells us we're done. We found all of our factors. Now we're going to go to 32 and list the factors of 32. 1 in itself, so 1 and 32. 2 and 16.
Yeah.
3, will 3 times something makes 32? No. Will 4 times something make 32?
Yes.
4 and
8.
8. 5 times something to make 32? No. 6 times something to make 32? No. 7 times something to make 32? No. 8 times something to make 32? Yes, the 4. So that means we're done. Now let's see what they have in common. They don't have a 32 in common. They don't have a 16 in common. They don't have an 8 in common. They have a 4 in common. So that's going to be our greatest common factor is that 4. So let's circle the 4. So we're going to write a 4 here and a 4 here. 28 divided by 4 is 7. And 32 divided by 4 is 8. So we're going to put an 8 right here. And now we all have left to do is label it. It's 7 cars to 8 trucks. Let's circle our answer. So now we're going to do equivalent ratios, find equivalent ratios using a tape diagram and utilizing the identity property. So we're going to write the ratio in fraction form. So let's highlight a few things. So we're going to write the ratio in fraction form, and we're going to utilize identity property and a tape diagram to scale up the ratio. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 5 to 3, and they wrote that ratio using a colon. If each unit of ribbon represents 2 meters, how much length does Shani and Mel each have? How about with 3 meters? How about 4 meters? Well, we're first going to write the ratio, and the ratio for this problem is 5 to 3, and we're going to write it in the form of a fraction. So we're going to put 5 over 3. Okay, the 5 represents Shani's ribbon. So I'm going to put 5 for Shani. So I'm going to put 5 for Shani. And then 3 is representing Mel's. I'm going to put Mel there. Okay, and then there's no identity property we're going to use for this to scale it up yet. We're just going to go ahead and show what 5 to 3 looks like as a tape diagram. So our tape diagram is going to be 5 squares for Shani and 3 squares for Mel. So we're going to draw, let's go ahead and draw a rectangle here, and we're going to break it up into 5 sections. Okay, and then for Mel, we need a tape diagram that represents her length of ribbon, and that's 3. And so we need to do 3, and we want each of the 3 boxes to line up with the first 3 of Shani's, because it has to be proportional. So we're going to line it up and separate it at the same points. So it looks something like that. Okay, so we wrote the original ratio and then we drew the tape diagram. What if each of those unit of ribbons represented 2 meters? So for this one, we need to scale it up by 2 because it says, what if each unit is represented by 2 meters? So we're going to scale it up by 2. So we're going to write the original ratio again, 5 to 3, 5 to 3, and now we're going to use identity property. So I'm going to write 5 to 3, and if I'm scaling it up, I need to multiply. And it's 2 meters, so I'm going to multiply the numerator and denominator by 2. And I'm going to be left with 10 over 6. So I scaled it up. Now, how is this going to look using a tape diagram? So I need to redraw the tape diagram again, so it's 5 to 3. So I'm going to draw a rectangle, break it up into 5 sections, and then the 3 for Mel's, and break that up into 3 sections, and please have each section line up. Okay, so if we're scaling it up by 2, then that means I need to put a 2 in each of those units, each of those boxes. So I'm going to put a 2 here, and a 2 here, 2, 2, 2, and every single one of them. Okay, well, there are 5 2's in that first tape diagram, so 2 times 5 is 10. And in that second one, there's 3 2's, so 2 times 3 is 6. So it's 10 over 6, just like what we did, or just like how we see it in the identity property. Now what if each unit represents 3 meters? So that means we're now scaling it up by 3. So we're going to write 5 over 3, again our original ratio. So 5 over 3. We're going to utilize the identity property, so I'm going to write it right here, and we're going to multiply now by 3. We're scaling it up by 3. So the numerator and denominator are both 3. Okay, 5 times 3 is 15. 3 times 3 is 9. So it's scaled up to 15 ninths. Well, what would that look like using a tape diagram? So we're going to go ahead and draw our 5 sections here, and then 3 down here. What's going to go in each box? We're scaling it up by 3, so that means we're going to put 3 in each box. Okay, that first tape diagram, there's 5 3's, so that makes 15. 3 times 5 is 15. There are 3 3's on that second one, so that's 3 times 3, and that makes 9. So our ratio then is 15 over 9, just like what we saw in the identity property. As our original ratio, 5 over 3. And we're going to utilize identity property to scale it up by 4. So we're going to multiply both the numerator and denominator by 4. 5 times 4 is 20, and 3 times 4 is 12, so it's 20 twelfths. So Shani's ribbon would be 20 meters long, and Mel's ribbon would be 12 meters long. If I'm going to use a tape diagram, I'm going to draw that 5 to 3 again. So I have my 5 and then 3. What's going to go in each of those boxes?
20.
4, because we scaled up by 4. And the first tape diagram, there's 5 4s, so that makes 20. And the second one, there are 3 4s, so that makes 12. So that's 20 over 12. And those are meters. So 20 meters for Shani and 12 meters for Mel.